A system has limited resources, and the more users you have, the greater the chances that they'll be competing for those resources. But luckily, we can monitor and manage how many resources an individual user is consuming. First, let's take a look at seeing how to determine what resources are being used by individual people. I'll switch over to one of my users here. And I'll start up a CPU-intensive process using the yes command, which types the letter Y and enter as quickly as it can, redirected to dev null, and I'll send it to the background. And then I'll go back to my other user here with exit. We can use the top command to see what's going on with the system. And up here at the top, consuming the majority of the CPU resources, is the command that user started. I'll press Q to quit top. I can use top with -u and a username to see only information about that user's processes, which is helpful to keep an eye on one user's activity without having to dig through all of the processes on the system. We can also check out the processes that a user has started with the ps command and the -u option to isolate an individual user. Let's get rid of that process by killing it by its process ID. While it's helpful to see what resources are being used, we can also be a little bit more proactive about resources and set limits on what users and groups can actually consume. The etc security limits.conf file, part of the PAM or pluggable authentication modules, serves as a place where you can limit the amount of memory, processor time, open files, process priority, and other resources by user or by group. The file itself and the man pages for limits.conf list all of the things that can be limited in the file. Let's take a look at the file and edit it. The format that we need to add items in is a user or group name, or a wildcard, and then whether the limit is hard or soft, that is, whether the system will cut off activity or just warn about it, and then the item we're limiting and the value of the limit. Let's scroll to the bottom, and we'll prevent the user Pat from creating files over 100 megabytes in size. So I'll write Pat, and this is a hard limit, and I'll use the fsize directive for file size, and set a limit of 100,000 kilobytes. I'll save that, and I'll exit. And now if I switch over to that user, and start to create some files, we can see the limit be enforced. These limits won't apply to users that are currently logged in. They'll be applied the next time the user logs in or starts an interactive shell. I'll write fallocate -l 10m and create a 10 megabyte file called 10m file. So far so good. Now I'll use fallocate -l to create a 100 megabyte file called 100m file. And there, when I try to create a 100 megabyte file, the system prevents me from doing so. I'll exit that user. You want to think through limits that you impose to make sure you're not making the system unusable for some reason or other. I'll remove this restriction from limits.conf for now. We can also limit the total amount of space that users and groups can consume on a given file system with quotas. The software for interacting with quotas is available in a package called Quota, so you may need to install it if that's not already been set up. I'll switch to my root shell and install Quota. Once that's installed, we can set up a quota on any connected file system by remounting it with support for either user or group quotas. We'd need to edit the FS tab to include that, and restart if we're setting quotas on the root file system. As a quick example here, I'll create a loop file system, which is a regular file that contains a file system, to explore how quotas work. I'll make a file with fallocate -l, and we'll make it 100 megabytes, and we'll put it at the root of the drive, called my file system. and then I'll create a file system inside it with makefs.ext4 and the path to the file system. Then I'll create a mount point for it. I'll write mkdir, mnt, and we'll call this one myfs. And then I'll mount it with the quota option, user quota, and the path to the device, and the mount point. And then we can create the quota files on the file system that has quota support with quota check-c and the path to the file system. Now I can use edQuota to set up a particular limit for a user or group. Let's pick on Pat again and set their limit on this file system. We can add a path to the file system we want to enforce quotas on, in this case my loop device, and then add the number of blocks or a size notation for how much the user is allowed to use. The hard limit is the one that really matters. That's the one that will cut a user off. Let's set that to 20 megabytes here. All right, I'll save that, and I'll quit. And I'll make sure my user can write to that file system. Then I'll run quota on and the path to the file system to make sure that the quota is enabled. Now I'll switch users. I'll go to that file system, and I'll create some files. And I'll switch to the file system. There's nothing here, so I'll create a few files with fallocate -l, and let's start out small with 15 megabytes. So far, so good. Let's try again with another 15 megabyte file. And there's the limit. This user can't consume any more space on this file system, but they could still write to other places they have access to. While they're logged in, they can use the quota command to see what their quota limitations are on each file system. I'll exit back to my root shell, and as an administrator, I can run the repquota-a command to see a summary or report of the quota status on my file systems. Quotas help to limit intentional or unintentional overruns on storage, making sure that your users are good citizens on the system. Just remember that file systems where you want to use quotas need to be mounted with the quota option, otherwise the limits won't be enforced.